One of the big cute things with carboxylic acids, they're acids, we've talked about that quite a bit, but they also are very easy to derivatize. Now I say that in quotes because, as you'll see, while there are 4 very important types of derivatives of carboxylic acids, only 2 of them are really useful synthetically, at least to make the others, and then the others have their own particular reaction chemistry. But anyway, here are the 4 big derivatives. First is acyl chlorides. Acyl chlorides look like this. You have the RC double bond O, and that's going to be present in every single one of these acid derivatives, and that's the acyl part. But instead of the OH, we have a chloride here. These are extremely reactive compounds. You have to be very careful of them around water, because if they see water, they will hydrolyze to make back the carboxylic acid. The way you name these is they are just have the suffix anoyl chloride. So this one here is ethanoyl chloride, coming from, of course, ethanoic acid, but replacing the OH by the chloride. This one here would be 1, 2, 3, 4, 5 carbons, so pentanoyl chloride, again from pentanoic acid, in which we replace the OH by the chloride. And finally, just for fun, when you have these groups attached to rings, you have to put in this extra little carbonyl group. Now, I could have mentioned this for aldehydes and ketones as well, but this is cyclopentane, there we are, carbonyl chloride. Okay, so a funny little extra additional name part when you have a carbonyl next to a ring. Acid anhydrides are the second most reactive of the acid derivatives. Acid anhydrides are simply this. Now, you can kind of picture this as taking one acid, so there's the RC double bond OO, so that's one acid, and then here's another part of an acid, RC double bond O. Well, this acid's lost the OH, this acid's lost the H, and of course H and OH make water. So it's 2 acids put together that have lost water, hence the anhydride. If acyl chlorides are the most reactive acid derivatives, which they are, acid anhydrides are the second most reactive. Again, you have to be very careful. If you have these close to water, then it's very careful for them to hydrolyze and get back to just the 2 acids again. Both of these very reactive with water, have to keep them away from water. The way you name them is just think about the 2 acids that you originally combined, use the names of those 2 acids and follow it up with anhydride. Thus, for example, this one here, this acid here was benzoic acid. This acid here was 1, 2, 3, 4, 5. So pentanoic acid. So benzoic, pentanoic, anhydride. If you have the same acid for both of them, and this is probably the most well-known anhydrides, it's just 2 acetic acids, so that's 1 acetic acid, another acetic acid. You don't call it acetic-acetic anhydride, you just call it acetic anhydride, or in this case, of course, ethanoic anhydride, but I've never met anyone who calls it anything other than acetic anhydride. So I've put the second acid name in brackets there. So 2 derivatives of carboxylic acids that are much more reactive than carboxylic acid, and that's really important that you remember that. Okay, acyl chlorides, where the OH is a Cl, and acetic anhydrides, where essentially the OH is another part of an acid. So acid chlorides, very, very reactive. Acid anhydrides, very reactive. Carboxylic acids, reactive. Now we'll come to 2 derivatives of carboxylic acids that are, in some cases, a little bit about the same reactive as acids, but generally less reactive than acids. First one of these, esters. Esters are this formula here where you have what was an acid, so the C double bond O, but instead we've replaced the OH with a part of an alcohol. So here's the R prime, O for the alcohol lost the H, the acid lost the OH, leaving out water, leaving you with this nice ester. The way they're named is you name the alcohol, alkyl group of the alcohol, followed by the alkyl group of the acid as the alkyl alkanoate. Now, esters are generally less reactive than carboxylic acids themselves, but sometimes an ester is a little bit more reactive, so it's a very bad idea to try to compare the reactivity of esters with the acids. What we can say is they are absolutely less reactive than acid anhydrides. Few examples here, and at the very end of the module I've got an entire movie all about esters because they're kind of fun. Anyway, so here we have ethyl ethanoate. So there's the ethanoate here, would have been acetate, acetic acid, so ethanoate. And then we have 1 carbon, 2 carbons to the O for the ethanol that was the alcohol used, giving us the ethyl, so ethyl ethanoate or ethyl acetic acid. So one here where our alcohol 1, 2, 3 propanol becomes propyl. The acid originally just the 1 carbon, so it was methanoic acid, so propyl methanoate. And then finally methyl propanoate, just to show you how the names change up, because here methanol was our alcohol and the acid was propanoic acid, 1, 2, 3 carbons. Finally, the least reactive of the acid derivatives, and these are really unreactive compared to acyl chlorides, many orders of magnitude less reactive. Amides, in which we have replaced the OH group of the original acid with NH2. These are simply named alkanamide, where this is the alkyl group there. So example there, butanamide, 1, 2, 3, 4 carbons, butanamide there. And then we have cyclopentane carbox to indicate that we got that ring, that the group is attached to the ring amide. Okay, so acid chlorides, very reactive. Acid anhydrides, very reactive. Acids, reactive. Esters, reactive. Amides, relatively unreactive.